This is my ALU circuit CAD design. This is input A, input B, input CIN, and these are the two select inputs, select 0 and select 1. And just to go briefly over the circuit, so this bottom 3/4 of the circuit deals with the Y output, and this part deals with the carry out output for addition when that's used. So the way it works is, in order to allow for multiple functionality based on the selects, based on the select 0 and select 1, we have 4 AND gates connected to either select 0 or not select 0, select 1 or not select 1, such that every possible combination of select 0 and select 1 lead to one specific set of gates to lead to the result happening. For example, let's start with 0 0, which means we're doing addition. If I give it a of 1, it gives me the result as 1. If I add another 1 to it, it gives me the carry out, which is 1, and 0, which is 2. If I also give it a carry in from a previous half adder, then you can see it becomes 1 1, because it's not only does the value of this position is 1, but it also carries out a 1 as well. So this is the 0 0 for selects, and it does addition. If it's 0 1, we change it to a subtract mode, and if I put 1 and 1, it gives 0 because it's like subtracting. If it's just a 1 and then it's a 1, or even if it's this is 1, it's also a 1, showing how it's subtracting these two numbers. So it's only 0 when these two inputs are 1, indicating a 1 minus 1 subtraction. So this is the second mode, which is 0 1 select. If it's a 1 0 select, it activates this AND gate to allow us to just use this gate for the computation. And this is an XOR gate, so in this mode we just have XOR for A and B. So if A is 1, we get an output of 1. If B alone is 1, then we get a 1. And if both are 1, then we get a 0. And the value of CIN doesn't matter in this case because it's just used for addition. And this is the XOR mode. If we have both 1 1s, then this AND gate gets activated by the two selects, and that allows us to accept the function, the output from this specific gate, which is in this case a NOR gate. And this allows us to so it's just a basic NOR. If I have 1 and 1, then it's still a 0. If I have 1 and 0, then it's still 0. If I have only when I have both zeros is it give me a value of 1. This OR gate right here allows us to accept input from any of these AND gates, and we know for a fact that only one can be activated at a time, so it allows us to switch between modes by just using the selects appropriately to get the desired mode that we need. Over here, this is the carry out circuit, and the way it works is, first of all, this is the AND gate that checks if both inputs are 1 and gives out a signal for the carry out, pretty much. And the way we activate it as well, and the way we activate it is using this AND gate over here, and the CIN is used with an XOR and AND gate with the A and B's to see if so in case there's a carry in order to be able to provide the right result for the carry out. So this part of the circuit right here deals with the carry out when we're doing addition, and it's only useful when we have both zeros, and that is what it's for. So this is my ALU circuit.